In this example, we are going to use a table rather than a Venn diagram to help answer these questions here. And it says, the table shows the number of men, women, and wheelchair entrants of the top 3 age brackets of the 2014 Boston Marathon. Now, this table is the universal set that contains our subset. So I'm just going to label this as our universal set. Now, Venn diagrams work very well when there are 2 or 3 subsets of a universal set. But for this scenario, we have 6 subsets that are addressed. We have men, women, and wheelchair entrants. And then we have these age groups, 18 to 39 years, 40 to 44 years, and 45 to 49 years. And a table such as this is often called a two-way table because the subsets are represented using rows that would be such as the men. These are rows. Rows go back and forth. They're horizontal. So here's one subset here. That's the men. Here's the other subset here, the women, another row. And here's another subset here. That's the wheelchair entrants. And then they're also broken up in columns. We have this column here that represents the 18 to 39-year-olds. This column for the 40 to 44 years, and then, of course, this one for the 45 to 49 years. Where the subsets intermingle or intersect is in the body of the table. Now, trying to illustrate this scenario using a Venn diagram, it just isn't feasible. So we use a table instead, which is just as effective. These numbers out here, these are often called marginal totals. So, for example, this total right here, this 12,594, that's the total number of men. So if I was to take 6,403, add that to 2,929, and then add that to 3,262, that'll give us a total number of men entrants of 12,594. This, of course, is the same idea. This is the total number of women entrants. And this one down here is the total number of wheelchair entrants. Same can be said for these totals down here. This 14,257. That's the total number of 18 to 39-year-olds. Add up 6,403. Add that to 7,814 and then to 40, and you come out with 14,257. This is the total for this column. And this is the total for this column. This total right here in the corner here is the table total. So if I was to add up all the entrants, I have a total number of 25,677 entrants here. Or I could go ahead and add up the row totals. I'll come out to be the same. Or I could add up the column totals. I'll also come out to be the same. So letter A says, determine the number of entrants who were men or 40 to 44 years old. So here are the men. I'm just going to outline it here. So we had 12,594 men or 40 to 44 years old. That's this group here. So if I wanted to know the number of entrants who were men or 40 to 44 years old, I would just add these two together. So I'd put down 12,594, add that to the 5,579. However, as you can see right here, this is our intersection right here. We have 2,929. That's being counted with the men, and it's also being counted with the 40 to 44 years old. So I have to take that out of there or I'd be double counting this group. So I'm going to subtract out 2,929. And that's going to give us a grand total of 15,244. So there are 15,244 men or 40 to 44-year-old entrants. And we'll do the same idea for letter B. Determine the number of entrants who were men and 40 to 44 years old. Well, that's this group right here. This number here is the 40 to 44-year-old men who entered the race. So we'll just put that down, 2,929. So you could see from earlier that in order to do one set or another set, we add the two sets together and then subtract out where they intersect. And finally, we'll do letter C. It says, determine the number of entrants who were 18 to 34 years old, or 45 to 49 years old, or in a wheelchair. So here, of course, is our 18 to 39-year-olds. There were 14,257. Here's our 45 to 49-year-olds. There are 5,841. And here are the wheelchair entrants. And there were 59 of them. So I would go ahead, and if I wanted to know this one or this one or this one, I would go ahead and add them together. So we'll take the 14,257, add that to the 5,841, add that to the total of wheelchair entrants. However, we do have intersections, and here's an intersection here and an intersection here, and of course we'd have to take that out or we'd be counting them twice. So I'll take out 40 and 2. So adding that all together gives us a grand total of 20,115. So you can see that a two-way table is just as effective as helping us solve these problems as a Venn diagram.